Very good afternoon. We are from a UPM students. Yes.
And we would like to make a video about the binomial probability distribution. Okay, firstly we want to introduce ourselves. Okay, my name is Muhammad Arif Rizaludin and my metric number is 178650.
Okay, and me, my name is Muhammad Razi Hafizat Zarodi. My matrix number is 177993.
Okay, the name is Muhammad Syamim Mojafri and my metric number is 180288.
And my name is Ahmad Fakir Samin Maisham and my metric number 181027.
Okay, we shall proceed to the binomial probability distribution.
Okay, now I would like to present about the binomial probability distribution. Okay, for binomial is one that possess the following properties. Is the probability distribution. Okay, for the first one is this probability is consists of n, which is repeated trials, and for trials, the result will outcome for the classify as a success or failure, hence the name or binomial. Okay, for the probability of success is denoted by P, which is remains constant from trial and repeated trials are independent. Okay, for the probability distribution of S, which is called binomial distribution. Okay, this is for formula for distribution binomial distribution. Okay, for PS is a probability. Okay, for C the power of nx is a combination of formula. Okay, P power of x, Q power of n minus x. Okay, for n is number of trials. Okay, for x, this x and this, which is the numbers 0, 1, 2 and any numbers until n. Okay, for P is a probability of success and the Q is a probability of failure. Okay, which is the example is Q equal to 1 minus P. Okay, that's all from the introduction. Thank you.
Okay, so for the first example of binomial distribution is I have set up this example. A die tossed 3 times. Okay, so a die has been tossed 3 times, and let's say that we take for the probability for the dice to have a result of 5. Okay, so for this example, find a P x equals 0, which means that the outcome is 5 as never come out in 3 times. Okay, so we can directly transfer the information given in the question to this formula, which is n is the number of trials, x is the number of outcome, p is number of successful, and q number of failure. Alright, so we transfer it directly to the formula and we got the answer 0.5787, which means that the probability for the 5 to come out in 3 times is 0.5787. Okay, the second one is if the number of 5 come out in 1 times in 3 toss. So directly transfer to the formula, we can get the answer is 0.34722. And last one is all of the dice have been thrown, come out 5, which is 3. So directly transfer it and we got the answer is 4.6 times to the 10 of negative 3. Okay, that's all for this example. Thank you.
Okay, hi, hello. Welcome back. Now I am going to explain to you all for the second example. You already seen first example, right? Okay, I want to explain for example 2. So this is more to application. Example 1 is a simple question for the binomial distribution. Okay, for the question is, in the old days there was a probability of 0.8 of success in any attempt to make a telephone call. So the question is, calculate the probability of having 7 success in 10 attempts. Means that they make 10 attempts to telephone call, and they want us to calculate what is the probability of having 7 success in 10 attempts. So, okay, we can say that probability of success P, we denote P as 0.8 of success, and remaining of failure means Q is a remaining of failure 0.2 to make up for 1. So denote as X here we denote as a success in getting through, means that a success. So because we want to find the success, so the probability of 7 success in 10 attempts, we use a formula P X equals to 7, and we use a combination formula. Since combination we don't need to, the arrangement we don't care actually, it's not like permutations. So C 7 out of 10, 0.8 power 7, 0.2 fail, means that this is P, this is Q, 10 minus 7. So the answer we get is 0.20133. This is the probability to 7 success in 10 attempts. If you want to transfer this into a histogram for better view, better clear, then we use this formula. You can see that formula, and then we transfer it to the histogram graph, and we should get like this. And this is what we call, you can see that this is what we call distribution graph. Okay, it's a simple question anyway. So that's for application or example 2. That's all from me.
Okay, my example is very simple. This is example 3. So what if a blindfolded man finds that the average that he hit is 4 out of 5, which means the success rate is about 0.8, and if he fire 4 shot, what is the probability of A more than 2 hits and B at least 3 misses? So for A more than 2 hits, which means probability of X greater than 2. So this is the data that I have gathered. X equals to number of hit that the blindfolded man shot. P equals to the successful hit, which is 4 over 5. N is the number of shot, which is 4. And Q is the number of miss, which is 1 over 5. And X naught equals to the number of miss. So for A, if he shot more than 2 hits, this equals to P of the shot X greater than 2. So PS greater than 2 equals to P probability of 3 shot plus probability of 4 shot. So this is by applying the binomial distribution formula, we got this formula, and then if we calculated, we got this answer. Okay, so this. So for B, what if at least he shot 3 misses? The 3 miss shot means 1 shot that hits and 4 and the other 3 miss. So for at least 3 misses, the probability of at least 3 misses is equals to probability of 1 hit and probability of no hit. So we applying the formula, then we got the answer. Then that's all.